All right, guys, this question asks us to determine the full rate law for a hypothetical reaction of A plus B goes to products, and I give you some data. Remember that the rate law, unless it's for an elementary process, and it doesn't say that this is an elementary process, is undeterminable unless you have some experimental data. And so we would write the rate law as equal to the rate is equal to the rate constant, and still K. I know that's confusing with equilibrium, but the rate constant K times the concentrations of the reactants raised to some power. And you will easily get confused if you automatically think that that power is going to be the stoichiometric coefficients, because that's not true unless it's an elementary process. And elementary processes will be specifically labeled as such. If it's not an elementary process like this one, then the only way to determine what the X and Y powers are is through experiment. And now this is what you have. You have some experimental data. And so what we're going to do is we're going to use that experimental data to simplify the rate expression to cancel out intermediates in order to solve for one of the variables X and Y at a time. So what you do is your goal is to look in the experimental table and find concentrations that don't change for one species, but do change for another species. Let's take a look at 3 and 1. In experiment 3, the molarity for A in both cases for 3 is 0.1, and for 1 it's 0.1. So in both cases it's the same, but it's different for B. It's 0.2 and 3 for B, and it's 0.1 for B and 1. So what we can do then is we can make a ratio of the rate expressions. And so if I take the rate for 3 and divide it by the rate for 1, then I can set that equal to the ratio of everything on the other side. So I would have K divided by K, and since it's a constant, it's going to be the same in both cases, divided by the 0.1 molar for 3 with respect to A, and the 0.1 molar with respect to A for number 1, in all raised to the X power. Then I do the same thing for B. In experiment 3, it was 0.2. In experiment 1, it was 0.1. And that's all raised to the Y power. And the reason I can do that is I'm taking advantage of this identity that A to the X over B to the X equals A over B all to the X. And so what happens? Well, then that means that this particular ratio is canceled because it just goes to 1. The same thing with the equilibrium constants. They go to 1. So the equation simplifies very nicely. On the left side of the equal sign, you get 2. 0.018 divided by 0.009. And on the right side of the equal sign, you get 2, but it's to the power Y. And now what we just use is we have to use our knowledge to solve for this, right? What power of 2 equals 2? Well, 2 to the 1. So that means that Y equals 1. So what we've done is we've figured out what Y is. Now we're going to do the same thing to figure out what X is, but we're going to find some experiments where the molarity of B stays the same in order to cancel it out. And so if we take experiment 2 over experiment 1, the molarities for B in both cases are 0.1. So 0.1, and the rates are 0.36 divided by 0.009, and that equals K over K. For A, it's 0.2 divided by 0.1, that's all to the X. And then for B, here they are, 0.1 over 0.1 to the Y. Again, that 0.1 over 0.1 is going to go to 1, so that's going to cancel out. It's going to leave me with 4 equals 2 to the X, so I get X equals 2. So I found out that X is 2 and Y is 1 But the last step in order to calculate the full rate law is to figure out what K is. So we go back up to the data that we get. We pick one of the data sets and we plug in everything that we know, because now we know everything except for K. So I'm going to choose, I think it's data set 2, and I'm going to plug in the rate. And this time I'm going to be real specific about the units. In the other cases, in the first example for Y, I showed you the units to make sure that you knew that they all cancel. In the second example for X, I didn't include any units because, again, they're all going to cancel. I wanted to save a little bit of time. But in this case, I want to show the units because it's going to be important, because the units for K depend on the order of the reaction. The rate of the reaction is always meters per molarity per second. The rate of the reaction is always molarity per second. So the units of K are going to be whatever they need to be in order to make the rate molarity per second once I've multiplied K by A to the second power and B to the 1 power. Now, when I simplify this, I'm going to get 0.36 molarity per second equals K times 0.04 molarity to the third. So I'm going to divide both sides by molarity to the third, and that way I get K equals 0.036 divided by 0.004 molarity cubed. And now, how's that going to cancel? Molarity cubed is going to cancel with the molarity at the top. I'm going to be left with molarity squared times seconds in the denominator. So I get 9.0 over molarity squared per second squared. And so if I want to put everything together, I'm going to write rate equals 9.0 molarities to the -2 times seconds to the -1 times the concentration of A to the second power times the concentration of B to the first power. And this is the full rate law. And that's what the question was asking you to get.